The point C1311 is on the line segment joining A and B. Point C has the property that the ratio of the lengths is 3 to 1. In general, suppose that the line segment AB is not horizontal or vertical, that C is on AB and that C is not on A or B. The ratio of the lengths AC to CB equals M to N. And that is when the x-coordinate of C splits the x-coordinate of A and B in the ratio Mn, and y-coordinate of C splits the y-coordinate of AB in the ratio Mn. Example above, determine the length of AC and the length of CB. All right, so let's see what we can do here. I think AC is just going to be using Pythagorean theorem. So that's going to be AC squared is 9 squared plus 12 squared. And then when you solve for that, you'll get AC equal to, I believe, 15. And then BC, well, that's just a 3, 4, 5 triangle. So some of you may not even need to do the Pythagorean theorem. But if you do, you can easily figure out that BC is 5. The point J55 is on the line segment joining G and H. Determine the length of the ratio of the lengths GJ to JH. Well, let's draw a little diagram here, and let's see what we have. So we've got G and H. So G is, 11, 2, so approximately here. And then H is 1, 7, so this is certainly not drawn to scale. And then we're going to draw, what is the J, 5, 5, so J is right here approximately. I mean, I have just to approximate it. So what they're saying really is figure out this GJ to JH ratio. Okay, so very similar to the diagram up there. We're going to make these little triangles, and that'll make our life easy. So let's label the H, which I believe was 1, 7. This was 5, 5. And this G was 11, 2. Okay, so if I could do this pretty quickly, I think this will be 2, and this is 4. And this one, 5. Well, hold on, something ain't right here. 11. No, it's right. So this is, I think, 6. And then this is 3. Yeah. Okay. So G, what are we doing here? GJ is the square root of 2 squared plus 4 squared, right? Using Pythagoras. So that's root 20. And then what's the next one? JH is the square root of 3 squared plus 6 squared. So that's, I believe, 45, root 45, right? Okay, so this ratio, therefore, is root 20 over root 45. And I think I can probably reduce that a little bit. Let's see, what is that? Root 5 and root 4, I think. And this is a root 5 and root 9. So that's basically 2 over 3. And that is the answer. Part C. Part C says, determine the coordinates of the point F on the line segment joining D and E so that the ratio is 1 to 2. All right. So again, let's see what I can do here. What are the points? 1, 6. Well, at least attempt to try to make it somewhat according to scale. And then what's the other one? E7, 9. Okay. So this is D and this is E. So let's draw that line. And then somewhere in between there's an F, right? So the F is like approximately there, I think. And they want you to figure out the coordinates of F. Okay, so, and they want it 1 to 2. Okay, let's draw those triangles again. And so from here to here is going to be 1, and from here to here is going to be 2, like 1x, 2x, like that. So what was D? It was 1, 6, right? So 1, 6. And then F was 7, 9. Or sorry, E was 7, 9. That's what I meant to say. So from 1 to 7 is 6, and we want to break it up into 3x. So 3x is 6, so x is 2. So this is 2 and this is 4. So that means this F, you're going to the right 2, so that's going to be a 3 there. And then by the same principle, we'll figure out the y coordinate. Let's say this is y, this would be 2y. And if you're going from 6 to 9, that's 3. So 3y is 3, so then y is 1. So this is 1, and this is 2. So if you're going up 1 from 6, it would be 7. So the coordinates of F are 3, 7. The point M75 is on the line segment joining K and L, so that the ratio of Km to ML is 3 to 4 to determine the values of P and Q. All right, same story here. Let's see what we can do. So again, we've got a line. We've got this K, which is 1Q. And then we have this L somewhere, and that's P9. And then we have M, so somewhere here, I think, probably. That's pretty decent to place. And then we draw our triangles. So as before, this is going to be, like 3x, and this is going to be 4x, and then this will be 3y and 4y, I believe. Okay, so do we have anything that we can use? I don't think so. The only thing we have going for us is just the fact that we know this ratio is 3 to 4. So this is L, right? Yeah. So let's just do that. Let's use the fact that P, I'm just trying to think here where, oh, M is given. Oh, I didn't even see that. 7, 5. Oh, that makes it easy. Okay, I was wondering, how do I approach this? Okay, well, then that makes it very straightforward. Then it's just, if you look at this coordinate and that coordinate, then P minus 7 over this 7 minus 1 is 4 to 3. Yeah. Yeah, exactly. So then you can easily just solve for P. Then that would be what? 6 times 4 is 24. 24 divided by, let's see here. 6 times 4 is 24. 24 divided by 3 is 8. So P is 15. And then by the same principle, you can figure out Q. So it'll be Q minus 5 over 5. Hold on, let me think about this. Q minus, or actually, I think I'm doing it the wrong way. 9 minus 5 over 5 minus Q. That's probably the proper way, is 4 over 3. And then this will be able to figure out the value for Q. So 9 minus 5 is 4. So 4 times 3 is 12. And then that'll be 20 minus 4Q. So 4Q is equal to 8. And then therefore Q is 2. So that's pretty much what they're asking for to determine the values of P and Q. In this problem, every 2 by 2 grid contains 4 non-zero positive digits, 1 in each cell. The sum of the 4 two-digit positive integers created by the 2 rows and the 2 columns of the grid ABCD is denoted by ABCD bracket. For example, 3498 bracket is 34 plus 98 plus 39 plus 48, which is 219. Determine the value of 7327 bracket. So we basically have to put in the two-digit numbers, 73, 27, 72, and 37, which is the 4 non-zero, the 4 two-digit positive integers created by the 2 rows and the 2 columns of that grid. And when you add all these guys up, it's 209, I believe. B, determine all pairs xy for which 5 BC 7 equals x b plus 1 c minus 3 y minus y, just y. All right, so let's do the same principle. It would be 50 plus b plus 10c plus 7. And then it would be 50 plus c. And then it would be 10b plus 7. And on the other side, well, a little bit more complicated there, would be 10x plus b plus 1 plus 10c minus 3 plus y plus 10x plus c minus 3 plus 10b plus 1 plus y. Okay, so I'll let you do all the math crunching here. When you do, you'll find something very interesting happens is the b's and the c's cancel from both sides. And all you're left with when you collect like terms is going to be 136 is equal to 20x plus 2y. Okay, and then you can reduce that a little bit further. 68 is equal to 10x plus y. And then what you do is you just kind of make a little table and try to figure out values of x and y. And these are integers, right? They're non-zero positive digits. So you take this formula and see what works. So let's see. When x, for example, is 1, you get 58 for y. But that's no good because y and x have to be digits, meaning either 1 through 9. So keep going. 2 would give you 48. 3 would give you 38. 4 would give you 28. 5 would give you 18. And finally, 6 would give you 8. And then 7 would give you minus 2. So the only one that works, that satisfies the criteria, is the 6 and the 8. So 6xy is 6, 8 is the only solution to that question. Determine all possible values of a, b, c, d minus a plus 1, b minus 2, c minus 1, and d plus 1. So the same story, be 10a plus b plus 10c, 10a plus b plus 10c plus d plus 10a plus c plus 10b plus d, okay? And then we're subtracting from that, subtracting from it this thing, so that's going to be 10a plus 1 plus b minus 2 plus 10c minus 1 plus d plus 1, let's see, plus 10a plus 1 plus c minus 1 plus 10b minus 2 plus d plus 1. Okay, and then I'll let you collect like terms and all that, and I'm sure you can do it. And when you do, you'll find it comes down to this: 20a plus 11b plus 11c plus 2d minus 20a plus 11b plus 11c plus 2d minus 11. And when you do that, everything cancels except the 11. So the only possible value for this whole thing is 11. Determine all grids for which ABCD bracket equals 104 and explain why there are no more such grids. Okay, so same story here. 10a plus b plus 10c plus d plus 10a plus c plus 10b plus d is 104. And then when we clean this up a bit, we get 20a plus 11b plus 11c plus 2d is 104. Okay, and let's see here. Where do we go from here? Well, all of these are positive, right? A, B, C, D. That's very important to remember. Are positive digits. So, and they're non-zero, right? They're non-zero. Let me go back. Yeah, non-zero positive digits. So they have to be at least 1 in terms of their value. A, like in B, C, D, whatever. So if there were at least one, so let's just say they were like B is equal to 1, C is equal to 1, D is equal to 1. That would mean that 20A would be 104 minus 11 minus 11 minus 2, right? So that's 20A is, that's 22, 24, so it'd be 80. So A would be 4. So A equals 4 is the largest A could be. So, and the smallest A can be, of course, is 1, since it's a positive digits. So A can be either just 1, 2, 3, or 4. So that's good. That gives us limited options, and therefore we can complete the question more quickly. Yeah. Okay, so let's do that. Let's start with A equals 1. And when we do, we get, now when we, this is sort of the equation we're working with, we get 11b plus 11c plus 2d is equal to 84. And therefore, 11b plus c would be equal to 84 minus 2d. And if we factor this a little bit more, we would get 2 times 42 minus d. And I think that's about as far as we can go there. So, from this, we have to sort of deduce or try to figure things out. So, D, let's see here. D has to be non-zero, right? So, if the smallest it could be is 1, so if that were true, wait, can D be 0? Let me think about this. In this problem, every 2 by 2 can get 4 non-zero positive digits. Yeah, they're all non-zero, so the smallest it could be is 1, which I think I already talked about up here. Yeah. Okay, just want to make sure. Okay, so if D was 1, then that means that this 11b plus c would be equal to 41 times 2, which is 82, I believe. So that means b plus c has got to be 82 divided by 11, which is what? About 7. So it's got to be less than or equal to 7, I believe. Yeah, so because it can't, I don't think it can equal 7, because if b plus c was, it would be 77, so that wouldn't work. So it's got to be less than 7, I think. Yeah, that's probably the better way of thinking about it. Let's go to the other extreme, which is if D is the largest possible, then that would be 11b plus c is, what is that going to be? 33 times 2, which is 66. 66, so that means b plus c is 6. Oh, okay, then we actually got a value. Okay, great. So that means when A is 1, D is 9, and b plus c is 6. Okay, so that means b and c, we can sort of make some pairs to make it 6. 4, 3, 3, 4, 2, and 5, 1. And now we can make our ABCD. So ABCD is either, well, they're all 1 and 9, right, for the A and the D. But then the B and the C, we've got these 5 scenarios. So 1, 5, 2, 4, 3, 3, 4, 2, and 5, 1. All right, great. So that's one set. And that we figured out for A equals 1. Now for A equals 2, I'll let you do that. There's no solutions. For A equals 3, same thing. There's no solutions. A equals 4, we'll go back to that original formula, 11b, 2d. It'll be 24 this time. And the only way this would work is if they're all 1. So this one is easy. This A, B, C, D is just 4, 1, 1, 1. So we got this one, these 5 basically, and this one. So those are the only ones that will satisfy the requirements of the original question stem. So I will let you read this whole big long thing and then just get right to the chase here. Suppose that L is 5, M is 3, R is 6, and then 7 people enter the room. In total, continue the chart above to show that where the 7 people sit and explain why each person 5, person 6, person 7 make their choice. Okay, so let's do that. So we have L, M, and R. So here we go. Initially, the numbers are 5, 3, and 6. And according to the rules of the question, person 1 goes where the number is greatest. So person 1 would go here. And then we continue to fill in the numbers. This is unchanged. This is unchanged. This will be 3 because of the fact that now it would have to be divided by 2 people if somebody went there. So before it was 6 divided by 1, now it's 6 divided by 2. Now the largest is this one, so that's where person 2 goes. And then we continue. This will now be 5 over 2 because it would involve 2 people this time. This is unchanged and this is unchanged. Now you have a tie, so you can go either way. So I'll just put person 3 here. I'm just really kind of just going by that pattern right there. No reason to change it. Now this is still 5 over 2. This is now 3 over 2. And this remains at 3. Now the largest of these is the 3, so that's where person 4 goes. This remains 5 over 2. This remains 3 over 2. This is now 6 over 3 this time, because these were 6 over 2s, these guys. So this is 6 over 3, which is, I believe, 2. So now the largest of these is this one, which is 2.5. So this is where person 5 goes. So now this would be 5 over 3, and this would remain at 3 over 2, and this would remain at 2. Of these, the largest, I believe, is this 2, so this is where person 6 goes. So now this would be 6 over 4, and this will remain at 3 over 2, this will remain at 5 over 3, and the largest of these, 1.5, 1.5, and 1.6. So this is where person 7 goes. So that is basically the way to put the people. Person 4, person 5, person 6, person 7. Explain why there cannot be positive integers L, M, R, 4, which the first 6 people who enter the room sit at tables in the following order: left, middle, right, left, left, left. Okay, so I guess we have to first create that and then prove why it cannot be done. Okay, so what do they want? So left would be person 1. And then middle, person 2. And then right, person 3. And then left, left, left. So the next ones will be all here. Person 4, person 5, person 6. Okay, let's see why this is not possible. Okay, I have no idea. So let me just see what happens. Okay, initially, the numbers were L, M, and R. And obviously, if P1 went there, and that means L was the greatest. That means L was either greater than or equal to M, and L was greater than or equal to R, right, according to the question. If it was a tie, then we just chose L, but at least we know that it's greater than or equal to. Okay, I think that's pretty much decent. Now, this would then therefore become L over 2. This would remain M. This would remain R. Now, if person 2 went for where that M is, then that basically means that this M is greater than or equal to R, and that M is greater than L over 2. Yeah. Yeah, I think that's the right way of thinking about it. And then the next one, we just keep going here. So let me just carefully see what this would be. This would be R. This would be M over 2. This would remain at L over 2. This would become let's see here. P4 goes there, so wait, hold on. I think this is, yeah, this is right. M over 2, L over 2. So this remains L over 2. This is M over 2. And now this becomes R over 2. And since P4 is going there, this has to be then L over 3. This remains M over 2, R over 2, and then this will become L over 4. Okay, so that's the correct way of designating that. Now, if you look at that row, that means that L over 4 had to have been greater than or equal to M over 2, which basically means that L over 2 is greater than or equal to M. But that contradicts this right here. These two contradict each other. Contradiction. So because there's a contradiction, that pretty much shows that that whole arrangement is not possible. Cannot be placed in that way. Suppose that L is 9, M is 19, is R 25. Determine with justification where position or person 2019 will sit. So this question obviously will be an extrapolation, because there's no way you're going to sit here and do everything from person 1 all the way up to person 2019. So we're going to have to see some sort of a pattern, and then we're going to have to extrapolate it to see what happens as you get up to that highest number. Okay, so let's start with that. This is going to be person 1, obviously. Let's just do a few and see what happens. And then this will be 25 over 2, which is 12.5, and this will be 19, this will be 9, so person 2 goes here. And then this will be 9.5, this remains at 12.5, and 9. So of these, the largest is this one, so person 3 goes here, and so on, right? Dot, dot, dot. But every 9th person we are going to have this column be a 9 over 9, which is a 1. Yeah. And then every 19th person this column will be a 19 over 9, which is a 1. And then every 25th person, this column would be a 25 over 25, which is a 1. So that basically means that the 9, 19, and 25, 9 plus 19 plus 25, which is 53. Every 53 is when you'll get down to sort of this 1, 1, 1. So that means if we're trying to get to 2019, and every 53 cycles we have sort of this division, then that's approximately 38 cycles. So 38 cycles. So we have 38 of these 9 guys. So let me see if I can fit that in here. So we have 38 cycles times 9, which is 342. And then in this one we'll have 38 times 19, which is 722. And then in this column it would be 38 times 25, which is 950. So that means by the time we got to there, the number will have been 9 divided by 343, the very next one. Yeah, because this would be person 2014, somewhere in here. I don't know which one, but yeah, because 38 times 53 is 2014. And then the person 2015 would come in that one of those 3, and then so on. So I'll insert what happens. So there you go. This is exactly what I was trying to show. We've got person 2015. We got 9 over 343 in the left column. 19 over 723. And then 25 over 951. As you can see there. And then you just keep going. For the next one, you just complete the table exactly the way you do it before. Which one of them was the biggest? Well, in this one, these are very close together, but this one is the biggest. That's why person 205 goes there. Now, if we go back, if you keep going, this one has to be divided by one more, and that's why we did 952 here. But these ones stay the same, 723 and 343. And among these three, they're very similar, but that one is the biggest. That's why P2016 goes there. And similarly, you do it for 2017, 2018, and 2019 in the same system. And when you do, you'll find that this number is the biggest. And that happens in that column, which is the left column. So the answer really to this question is that P2019 sits at the left table.